Hey, welcome back to the most curious corner of the internet. Here, every tiny fact rewires the way you see the world, one spark at a time. A quick flash of light cuts through the dark. Alright, let's jump into today's surprising twist. What if life in the universe is actually common, not rare, not miraculous, just waiting for us to notice? Right now, telescopes are staring into the darkness. Robots are drilling into alien soil. And scientists are quietly narrowing down the cosmic neighborhoods where life is most likely hiding. Not guesses, not sci-fi fantasies, real targets. So today, let's run a thought experiment, a serious one. What if we asked science a simple question? If life exists beyond Earth, where should we look first? And the answers, they're way stranger and way closer than most people think. For most of human history, the universe felt hostile, cold, silent, dead. But over the last few decades, something unsettling happened. We discovered organic molecules floating in space. Water everywhere, frozen, vaporized, hidden underground. And planets everywhere, trillions of galaxies. Hundreds of billions of stars in each one, most with planets. At that scale, silence starts to feel suspicious. So scientists stopped asking, is there life out there? And started asking something much sharper. Where does life actually have a chance? Astrobiology, the science of life beyond Earth, doesn't chase aliens, it chases conditions, and so far, life seems stubbornly picky. Based on everything we know, it needs three things. First, liquid water, not ice, not vapor, but water that can flow. Second, organic molecules, the chemical Lego bricks of biology. Third, energy, heat, chemistry, or sunlight to keep reactions alive. Find all three in the same place. Now, you've got a serious contender. And that realization rewrote the map of the search for life. Let's start with a moon that looks completely dead. Europa, one of Jupiter's moons. A frozen white marble. But beneath its cracked ice shell, an ocean, not a puddle, a global ocean, deeper than all of Earth's oceans combined. And here's the twist. Europa isn't just wet. It's warm. Gravitational squeezing from Jupiter heats its interior, possibly creating hydrothermal vents on the ocean floor. On Earth, those exact vents are packed with life. No sunlight, no oxygen, just chemistry and heat. So if life can exist anywhere without the sun, Europa just jumped to the top of the list. Now, let's get even weirder. Enceladus, a tiny moon of Saturn. This one doesn't hide its ocean, it sprays it into space. Massive geysers blast water vapor, ice grains, organic molecules, even hydrogen, straight out of cracks in the ice. The Cassini spacecraft flew through those plumes, and what it found shocked everyone. Organic compounds, salts, chemical energy. Basically, Enceladus is yelling, hey, there's chemistry happening down here. If Europa is a locked vault, Enceladus is an open window. Then there's Mars. Today, dry, cold, harsh, but billions of years ago, Mars had rivers, lakes, maybe even oceans. We've found ancient riverbeds, minerals that only form in water. And here's the intriguing part, methane. Methane appears in Mars' atmosphere, then disappears. On Earth, methane is often linked to biological activity, but on Mars, geology can also produce it. Right now, there's no scientific consensus. That uncertainty is exactly what makes Mars compelling. If life ever existed there, even microbial, it may have left traces, or adapted underground, waiting to be found. Now imagine a world with rivers, lakes, rain, but not of water. Titan, Saturn's largest moon, is soaked in liquid methane and ethane. Its thick atmosphere is packed with complex organic molecules. Cassini detected compounds like vinyl cyanide, a molecule that could theoretically form membrane-like structures in methane-based environments. This doesn't mean Titan hosts life, but it shows something remarkable. The chemistry needed for organization for complexity is already there. Titan may not host life as we know it, but it could host chemistry, learning how to become alive. Here's where things truly escalate. Everything we've talked about so far is just our cosmic neighborhood. Beyond it, we've confirmed thousands of exoplanets, some rocky, some Earth-sized, some orbiting within the habitable zone. Early observations, like K218b with the Hubble Space Telescope, hinted at water vapor. Now, the James Webb Space Telescope is refining those measurements, looking for methane, carbon chemistry, and even tentative hints of molecules like DMs, which on Earth are strongly associated with life. Nothing confirmed. No announcements of aliens, but the chemical picture is becoming clearer and harder to ignore. Here's the quiet revolution happening in science. Life on Earth didn't take billions of years to appear. The earliest evidence suggests it emerged around 3.8 to 4.1 billion years ago, shortly after the planet cooled from intense bombardment. That timing matters. It suggests that once conditions stabilized water, chemistry, energy, life didn't hesitate. Matter didn't wait. It organized. If that's true, then life isn't a cosmic accident. It's a process the universe knows how to run, which makes the universe feel less empty and more unfinished. And now, the timeline gets serious. We're not guessing anymore. We're deploying missions. NASA's Europa Clipper, arriving around 2030, will analyze plumes, ice thickness, and the chemistry of Europa's hidden ocean. Dragonfly, launching to Titan in 2028, will fly across its surface, directly sampling organic chemistry in one of the most complex environments we know. Meanwhile, James Webb continues scanning exoplanet atmospheres, searching for chemical imbalances that physics alone struggles to explain. The next discovery may not be the dramatic one. It may be subtle, a ratio, a pattern, a mismatch. And that may be enough. Thanks for hanging out till the end. Love having curious minds here. If this sparked something, hit like, subscribe, and tap the bell for the next drop of wonder. And if you're still in discovery mode, pick another video. It gets even better. See you in the next one.